All right, guys. So let's start. So let's start from here. So let's talk. So how DFS accept languages? So let's take this language. Let's assume my sigma is a comma b. My language is all strings length greater or equal to 2. What would be the DFA for this? What would be the DFA for this?
So এই যে কয়েকটা স্টেটস হবে স্যার লেংথ 0 এর জন্য লেংথ 1 এর জন্য
Okay, so I have first state length of 0. Then I have another state length of 1. Then I have another state. Let's say this is nothing but length of greater or equal to 2. Our stated closure because 2, 3, 4, 5 we can accept in the same state. So starting from here, then seeing A, comma B, I'm going here. So length 1. Then I'm going to seeing another A or B, I'm going to link to. After that one, whatever comes, I'm going to accept it. This would be my first stage. Let's take another language. Let's say my language is all strings length greater or equal to 3. So what would be the DFA for this? How many states would be there?
So 1 2 3
Four.
4
4 state. I have to increase the state in this problem because right now I have to also consider separately length. Right now I'm not going to accept length 2, but after that one I'm going to accept. So length 2 should be separate state. So I have to increase the state now. So length 0, this should be separated. Length 1, this should be separated. Length 2, this should be separated. Finally, I have length greater or equal to 3. Epsilon. Seeing a letter A or B, I'm going to length 1. Seeing another letter, I'm going to this one. Seeing another letter, I'm going to this. Then finally, whatever comes, length 3, after that one, length 4, length 5, length 6, I'm going to accept it. So understand actually one thing, DFA does not have any memory. DFA does not have memory. Then when it requires to remember something, what it is going to do? Tell me. When it requires to remember something, what it is going to do?
স্টেট বানাবে
Increasing state. Good, very good. Increasing the state or creating new state. খুব সুন্দর. But is that enough? Is that enough? That means it does not have any memory, fine. Does not have any external memory. Whenever it requires to remember something, it increases the state. Now, is that enough? That means can we do everything using DFA? Everything means accepting all languages. using DFA? What is the question? This is the question. Can we do everything? That means accepting all languages using DFA. What do you think? Is it possible? Hmm? Is it possible? What should be the answer? We are going to take any language. Can we come up with a DFA? Is it possible or not? কথা বলেন ইয়েস না একটা কিছু বলেন
স্যার মেবি কোনো লিমিটেশনস আছে ডিএফএ
so then give me a language which cannot be accepted by DFA. Can you have any language? Let's take this language. Sigma equal to a comma b and my language is a and so at first I'm expecting a, then I'm going to expecting b, and the number of a and b should be equal and they should be greater or equal to 1. Can we have a DFA for this language? Tell me.
Yes, sir.
Can we have a DFA for this language? কথা বলেন let's try
Sir, এটা কোনো DFA
let's try to draw a DFA. So what should be my strategy? My strategy will be like this. My language is like this. A to the power n, b to the power n, and number of a and b should be equal. Initially I got all the a, then I should expect all the b. Okay? So like this. Let's try to draw a DFA. Let's try. There is no harm to trying. So initially I'm expecting A. Initially if I expect B, I'm going to death state and I would remain in the death state. Then if I get A, I'm going to new state. Then what happened?
Sir, A, B,
I
তে
get
যাবে
lot of A, I should remain in the same state. So I'm done with A. Then I get B. Then I'm going to new state. And then I'm going to expect as many B as I want and I'm going to accept it. Am I right?
Sir, A, the last state, final state A, death state যাবে না?
Yes. এখানে যদি আবার আমরা A পাই, I would go to this state. Right? Any problem?
No, sir.
Okay, so let's take a string. Let's take A, 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 B, B, B. So let's number this A, B, C, D. A, seeing A, I should go to B. B seeing A, I should remain in B. B seeing A, I should remain in B. In B, I'm seeing A, small b, I'm going to C. C seeing B, I should remain in C. C seeing B, I'm remaining in C, and C is a final state. So I'm going to accept it. Am I right? I'm going to accept it. Am I right?
Yes, sir.
Okay.
Yes.
Now, what happened? And definitely this string is belongs to language. Am I right? Now, how about this? A, B, B, B. Is this string belongs to language?
No.
No, why not?
স্যার A এর পাওয়ার হচ্ছে 2 আর B পাওয়ার
Good. তার মানে they are not same. So let's try to traverse this string. So from starting A, seeing A, I should go to B. From B, seeing A, I should remain in B. B seeing small b, I'm going to C, then C, then C. It is accepted. So what is the meaning of this? Still it is accepted. what is the meaning of this?
So the
It
language
means
that the
it,
GFA takes.
it means this DFA. It means this DFA not only accept string belongs to language, but also some strings not belongs to language. Do you agree with me or not? Am I right?
Yeah.
So it
Yes,
is
sir.
what? It is a violation of what? Violation of
Language.
definition of DFA. Because we know that DFA should only accept those strings which belongs to language. Am I right or not?
Yes, sir.
Yes, sir.
So it is accepting superset of the language. That means it is not fulfill our purpose. In fact, you cannot come up with any DFA which is going to accept this language. Did you get it? Did you get it? Now, what can we make change so that we can accept this language? Tell me, what would be the strategy? How can we accept this language? What else we can do to accept this language?
স্যার এ আর বি এর পাওয়ার ডিফারেন্ট করে দিলে
না, সেটা তো করতে পারবো না। Language I cannot change. I try to accept this language. So how can I accept this language? How can I accept this language? I cannot change the power. No. How about this? Let's assume I have a stack. I have a stack. Initially, this stack is empty, and this is my string. A, B, B, B. So when I get a, what I'm going to do? I'm going to push. When I get another A, what I'm going to do? Push. When I get another A, I'm going to push. When I start getting B, what I'm going to do? Pop here, here, and here. Another thing, I get another B, I remove here and here. And I get here B, I remove here and here. Then what happened? If it is empty, the stack is empty, and the buffer is also empty, I will say the empty matches empty, we are going to only accept. Did you get the point?
Yes, sir.
How about this? Now if you take this string, A, B, B, B. Now initially my stack is empty. So I get A, what I'm going to do? Push. I get another A, I get push. I get B, I'm going to pop. I get another B, I'm going to pop. But this becomes empty, but this is not empty. I get phi and B. What I'm going to do? Reject. Did you get it?
Yes, sir.
So that means if we incorporate finite automata plus a stack of infinite memory, then we can accept language AN, BN, and greater equal to 1. Am I right? And this is nothing but called push down automata. Push down automata or PDA, and which is more powerful than finite automata. Did you get it? So whenever finite automata has stack, infinite stack, then it becomes more powerful, and that time it starts calling what? কথা বলেন।
Stack.
Whenever a finite automata has some sort of stack, infinite stack, then we call it what?
পুশ ডাউন
Push down automata.
push down automata or PDA, and PDA is
More powerful than FA.
so PDA, and remember this PDA is more powerful than finite automata. More powerful than finite automata. All right, guys. Did you
Yes,
get
sir.
it?
Yes.
এখানে দুটো জিনিস খুব ইম্পর্টেন্ট। এখানে দুটো জিনিস খুব ইম্পর্টেন্ট। এখানে see when we stuck এখানে কয়েকটা জিনিস ইম্পর্টেন্ট। এখানে কয়েকটা ডেফিনেশন লিখি। When we stuck, what is the meaning of stuck? What is the meaning of stuck?
একটা স্টেটের মধ্যে ইয়ে হয়ে আছে, লক হয়ে আছে।
Lock হয়ে আছে। When we stuck, that means we cannot move further in buffer and or stack. When we stuck, that means we cannot move further in buffer even, or and of buffer, which is also another kind of stuck. The state is called what? Halting. It is একজনের নাম, holding না. It is not holding. It is the name of a person, very famous computer scientist. Halting state. It is called halting state. Halt is the name of a computer scientist, and according to his name, it is called halting state. And actually, the things matches. Halt matches. Halting state. So here, where we halt? Here, where we halt? Here, why we halt? Here, why we halt?
যখন স্ট্যাকের মধ্যে কিছু বাকি থাকে,
যখন স্ট্যাক ও এমটি আর বাফার, যখন বাফার মুভ করবে না তখনই আমরা হল্ট। এখানে আমরা বাফার কোনখানে হল্ট করেছি? হোয়াট ডিড উই হল্ট হিয়ার?
যখন স্ট্যাক এমটি তখন আমরা থেমে গেছি।
তখন এখানে হল্ট করেছি। তার মানে এখানে হল্ট হচ্ছে একটা অ্যাকসেপ্ট, হল্ট স্টেটটা অ্যাকসেপ্টিং। এম আই রাইট? কারণ দুইটাই এমটি। এম আই রাইট? এখানে আমরা কোথায় হল্ট করেছি?
সো বিতে।
এখানে আমরা হল্ট করেছি বিতে। এন্ড এখানে দুটো এমটি না, তার মানে এখানে আমরা হল্ট করেছি একটা রিজেক্টেড স্টেট। ডিড ইউ আন্ডারস্ট্যান্ড?
জি স্যার।
That means buffer, whenever we cannot move any further in buffer, that is the halting state or empty of the buffer. And when we halt in accepting state, that means we are accepting the language. Whenever we halt in a rejecting state, we are rejecting the language. Okay? Or rejecting the state. Is it the most powerful machine? Whenever we apply finite automata with stack, is it the most powerful machine? Can we improve it more? Is it possible? How about this? Take this like this. My alphabet is A, B, C. My language is A, N, B, N, C, N. Tinta. And N is get referred to. How can you accept this? How can you accept this one? Tell me. PDA is enough? How about PDA? Push down automata দিয়ে কি একটা accept করা যাবে? Can we accept this using PDA? Push down automata? কথা বলেন, please.
স্যার
Yes, I'm-
স্যার দুইটা স্ট্যাক ইউজ করতে হবে তো
Duta stack. No, don't use two stacks. Only one single stack. I'm going to tell you the reason behind it. Not using two stack later. So what's wrong with this? What's wrong with this? I know there are three variables. So what happened? Let's try. So let's take this. A, B, 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 C, C, C. So initially my stack is empty. Then what happens? Say apply the same things. I get A, push. Get A, push. I get A, push. Then I get B, pop. I get B, pop. I get B, pop. Yes, I know that equal number of A and B. It is empty now. Now what happened? You don't have any information about A, you don't have any information about B. So how can you accept the equal number of C? Did you get it? Big question mark. Because you lost everything. You lost everything. You lost everything. So using PDA it is not possible. So what can I
So if there were four
using
variables,
instead of
স্যার চারটা ভেরিয়েবল হলে কি করা যেত স্যার এটা?
data variable are difficult. Let's talk about three variables. Why you are jumping like spider?
স্যার পিডিএ দিয়ে কি তাহলে শুধু দুইটা ভ্যারিয়েবল দিয়ে করা যাবে
So we understand PDA is more powerful than Finite Automata, but PDA cannot do even all the languages. PDA cannot even accept all the languages. So PDA has some limitations. So what else we can do? What type of data structure is used in PDA?
Stack.
Can we use more powerful data structure to improve PDA?
Sir, queue, but
Good, very good. So how about this? So two stack acts like a queue. Two stack used like a queue. Okay. So what can we do? Instead of taking stack, we can use a queue. We can use a queue or some sort of linked list, single linked list. Let's call linked list. Queue is little bit complicated. So instead of stack, we are going to take Finite Automata plus linked list, some sort of linked list. So if we take a linked list, how can we accept this like this? How can we accept this? Tell me, what would be the strategy? In my buffer, something like this. How can I do that? Any idea? Now we are taking linked list. We can move from here to here. We can also move from here to here. क्या आइडिया क्या आशा ना? No idea. Tell me.
No, sir, no idea.
No idea. Who is this? Who is this? No idea, girl.
Sumedha.
Huh?
Sir, Sumedha. Blank ekdom, sir. An idea.
Sumedha. Sumedha, girls are very creative. You should have an idea.
এতক্ষণ তো বলতে পারলাম এখন কিছুই কাজ করছে
এখন কিছুই কাজ করছে আর কোন গার্লস বা বয়েজ এনি আইডিয়া আমরা we can move from left to right and right to left, left to right, right to left, left to right, right to left. What can we do?
স্যার সার্কুলার লিংক লিস্ট ইউজ করব।
Ish. Oh. Linked list is enough to solve this problem. We do not need to have more complicated data structure. How can I do that? Tell me, how about this? We are going to remove 1A here, 1B here, 1C here. Then we again remove 1A here, 1B here, 1C here. Again we are remove 1A here, 1B here, 1C here. Now it becomes empty. So we are going to accept. Do you agree with me or not?
Yes, sir.
Because we can move left to right to left. Stack we don't have this movement, but in linked list we have this kind of movement. Am I right?
Yes.
Right? That time, whenever we use finite automata plus linked list or more flexible data structure, this is very crude definition. Then stack, we call it is called linear bounded set. Linear bounded automata. Linear bounded automata. Is this the most powerful machine? Tell me. Huh? Is this the most powerful machine? Can you improve it more? Can you improve it more? More. How about this language? Let's take this language. खूब simple language. A to the power m. N is 2 to the power m. M is greater or equal to 0. Can we accept this language as a linear bounded automata? So what are the strings inside this language? What are the strings inside this language? বুঝা গেল এটা তো সিঙ্গেল there is only single alphabet, there is only a single letter inside this alphabet, only A. Still we cannot find out any finite automata for this. Still we cannot find out any push down automata for this. Still we cannot find out any linear bounded automata for this. What are the strings inside this language? Tell me. When m equal to 0, then 2 to the power 0 equal to what? When m equal to 1, 2. When m equal to 3, কত? m equal to 2, 4. m equal to 3, 8. So it is something like this. A, 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 so on. So this way. Exponential it is increasing, number of A. You cannot find any finite automata. Forget about finite automata. Forget about push down automata. Forget about linear bounded automata. You have to come up with more strong data structure, more strong machine. So what is that machine? That is called Turing machine. That is called
Turing machine.
Turing machine. Who is Turing?
So Alan Turing.
Alan Turing. কি জানি movie? What is that movie? What is that movie called? An Incredible Mind or something like that. Turing machine. So what is
So the imitation game.
the imitation game? Okay. So Turing machine. What is Turing's machine specialty? It can take some decision. At a state, you can take either this path or that path. So this kind of decision-making capability is present in Turing machine. That time it becomes more powerful. And this Turing machine can accept this kind of languages. Seems very easy, but need Turing machine. Now, what is the specialty about Turing machine? What is the specialty about Turing machine? It is considered the most powerful machine in the world. in earth লেখো ওয়ার্ল্ড বললে আবার একটু আমি আবার এগুলো বিশ্বাস করি না তো আচ্ছা it is considered the most powerful machine in earth that means no matter how complicated machine you are going to make you cannot get more powerful than Turing machine that is the ultimate machine human being can make and basically actually Alan Turing actually has a in his PhD thesis he has shown that this is the ultimate machine. We cannot get more powerful machine than Turing machine. This is the ultimate concept. Okay, so you can tell me this, sir. Our computers are Turing machine. Yes, they are Turing machine. Then you can also say, sir, how about C, C++ languages and other languages? Are they Turing compatible? Yes, they are Turing compatible. Any computer languages which has the if-else structure, if-else, the conditional structure, that is actually Turing compatible. Any language which has if-else structure is called Turing complete language. That means we can find a Turing machine for this, and that is the most powerful language. Is it clear to you? If you have any query, you can ask me. Tell me.
Sir,
Yeah.
sir,
Yes.
how can we make a machine which can decide? Like,
Same way, how in a
can we
language we can, how in a language we can decide that should we go to left or right? Checking
Yes, sir. So
checking if
there is a comparison, like
comparison. So Turing machine has some criteria by which it can understand right now this is the state. Next time this would not be state. The state would be changed. So something like this. It's a good question, but too high for you guys. So initially like this. Let's say খুব সুন্দর কোশ্চেন আপনার কোনো আইডিয়া আছে আপনি কোশ্চেনটা করেছেন do you have any idea
no, sir. So I'm,
who is the person
sir,
asking question
sir,
Who is the-
Umar, sir.
Omar Ajabe is it your retake course
No, sir.
then tell me your experience tell me please well listen
It's like, so when we did the labs for digital logics, when we did
please
labs for,
say clearly we don't understand
so যখন আমরা ল্যাব করতেছিলাম ডিজিটাল লজিক্সের স্যার তখন একটা কোয়েশ্চেন স্যার ওখানে আমরা করছিলাম এটা নিয়ে স্যার কেমনে ডিসিশন মেকিং এর হয় মানে ডিসিশন মানে রাইট আর লেফটে যাব এটা স্যার কোনটাই
good হ্যাঁ left or right তো আমি linear bounded automata তো we are going but why the Turing machine is special
So,
that is the question of you right
আমি স্যার Yes, sir. Sir, আমি ওটা জিজ্ঞেস করছিলাম আমার স্যারকে স্যার আমরা যখন
which
C++ এর ল্যাঙ্গুয়েজ
okay after the language you
Sir,
okay
digital
in the
logic.
language you know how to take decision right in the language you know how to take decision
Yes, sir.
for example there is a var equal to 5 if var is equal to 5 then std cout print out 5 std handle right and else std cout 0 still Grameen phone makes me lot of pain calling from 2400 whenever I receive this call they start singing
Sir, block it.
I do not want to waste my one of the block list. Come on. Okay. So you know, using language, how can you take decision, right? Okay. Now,
Yes, sir, yes, sir.
how in the Turing machine you can take decision? For example, this is my buffer. This is my buffer right now. There are some places over here and over here, right? Right? Initially, let's say it is A. All right?
Yes.
You know that
Yes, sir.
when it is A, I'm going to do something. Let's say do something more. All right, guys.
Yes, sir.
Now in Turing machine, you can also delete any middle entry of the buffer. So now let's assume I delete this A, make it blank. Did you get it? Blank is a special symbol included in Turing machine. Then when I get A in my finite automata, I say do something more. And whenever I get blank, I'll say do something two. Plus, decision is taken. Did you get it? Did you get it or not?
Sir, unclear আছে idea.
Huh? What happened?
So I said the idea is a bit unclear yet still now.
I don't get you. What is he telling? Can
Sir,
anybody explain?
idea clear না বলতেছে।
Idea clear now. Why idea is not clear? Why idea is not clear? And in a state, in a finite automata, whenever we get A, we are going to a new state. And whenever we get B, we are going to a new state. Now in same thing also happening. In a buffer's place, whenever I get A, I'm going to this state. Whenever I get blank, I'm going to a new state. So decision making is happening for the same entry, same point. This is the same point.
Okay, sir. Sir,
This is the same point of buffer.
understood, sir.
Okay, good, very good. Okay,
Understood, sir. Thank you,
same
sir.
point, same point. So this is the case. Okay, don't take it so hard. Now, let's make the classification. And remember, Turing machine is considered the most powerful machine in the earth so far, according to Turing's thesis. Okay. Now, let's make the analogy. Great analogy. So, remember, it is something like this. So, I have the least powerful machine, which is nothing but finite automata. Then I have little more powerful machine, which is nothing but push down automata.
Yes.
Then I have more powerful machine, which is nothing but linear
Linear.
bounded.
Linear.
And ultimately, I have the final machine, which is nothing but Turing machine. Let's give you an example. Finite automata can accept this language. A and n greater or equal to 1. Push down automata can accept this language. A and B and greater or equal to 1. Linear bounded automata can accept this language. A n, B n, C n, and greater or equal to 1. Turing machine can accept this languages. Let's say A, P is the prime. Or I have given an example. A 2 to the power m greater or equal to 0. These languages can accept by Turing. So this is the automata part. Now, each automata has a equivalent language. So, finite automata language is called, tell me please. Finite automata language is called, why don't they speak? Finite automata languages are called regular language. Then push down automata languages are called, those are called context free language. or CFG. Then linear bounded automata languages are called context sensitive language or CSL. And finally, the Turing machine accepting languages are called recursively enumerable set or RES. This is not bad. Each automata has a equivalent grammar. Each automata has a equivalent grammar. The grammar accepted by finite automata are called regular grammar or RG. The grammar accepted by pushdown automata is called context free grammar or CFG. The grammar accepted by linear bounded automata are called context sensitive grammar or CSG. And finally, the Turing machine capable grammar are called what? Unrestricted grammar or UG. Do you have any query? If you have any query, you can ask.
No, sir.
Okay, sir. All right. So let's start a new topic because you people are very behind than others. Let's try to prove a theorem. You understand? J, sir, I understand. The finite automata, it has equivalent regular language and it has equivalent regular grammar. Now, sir, how can you prove that? If you ask me, yes, sir, how can you prove that regular language and regular language, any regular language can be accepted by finite automata or any finite automata has a equivalent regular language? How can you prove that? Can you believe me? Tell me, please. Can you believe me that any finite automata has a regular language and any regular language is a finite automata? I just said this to you, but do you believe me? Tell me.
Yes, sir.
Yes,
You
sir.
believe me? Why? I did not prove it yet. Why do you believe me? After proving, then you will believe me that it is fine. But without proof, why do you believe me? So let's try to prove this. Theorem. Any regular language if and only if accepted by equivalent any regular language if and only if accepted by equivalent effect. We are going to prove. So before proving this, we need to know what is the definition of regular language. Regular language. So what is the definition of regular language? The minimum subset of languages the minimal subset of languages which is closed under union, concat, and cluster is called RL, regular language. So this is the definition. So we know that there is nothing to prove in regular proof definition, because definition will define the regular language in this. All right, guys. So let's try. So there are very few important things there. One is actually closed standard. What is the meaning of closed standard? We know what is union, concat, and cluster, but we have to prove, or we have to find out what do we mean by closed under, union, concat, and cluster. So let's start. Do you have any query? You can ask me. Many times it seems to me you people don't listen to me. Is it correct or not? Tell me.
No, sir.
Are you listening?
No, no,
Yes,
sir.
sir. Listen.
জি স্যার শুনতেছি স্যার।
Teacher.
জি স্যার।
Yes, sir.
So what is union? What is union? What is union? What is union of two languages or one union of finite automata? So language 1 is AA, AB, and language 2 is BB, BA. Then what is the union of L1 and L2?
এ এ এ বি 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 বি।
Good, very good. So this is the union. What is concat of two languages?
A, A, B, 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 A.
L1 is, let's say, AA, AB, and let's say L2 equal to BB, BA. Then what is the concat of these two?
Sir, how do you concatenate?
L1 যেভাবে করতে হয়,
L2 or L2 L1?
A, A, B, 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 A.
then what is this? AA, BB, AA, BA, AB, BB, AB, BA. This is the concat. Our cluster, if sigma equal to A, what is the cluster of, what is the L of A star? What is this? What is the cluster? What are the set? Epsilon, A, so on. Short. Good. So we understand what is cluster. Now, what is closed? What is closed under? What is the meaning of closed under? Union, concat, and cluster. It means if if L1 and L2 are two languages, then L1 union L2 is also regular languages. Then L1 union L2 is regular language. L1 concatenate L2 is regular language, and L1 plan star or L2 plan star is also regular language. So this is the meaning of closed. This is the word closed. This is the meaning of word closed. All right. Do you have any query? Yes, no, no, yes. Now we're going to prove another short theorem
Also,
to prove the main theorem, which is called lemma. Which is called lemma. What is that called? What is that called? Yes. What is that called?
Sir,
Come
lemma is
on.
a short theorem.
Lemma. Lemma is a short theorem to prove the main theorem. So what is my lemma? My lemma is finite automata is also closed under union, concat, and plan star. So I'm going to prove this. Proof. Okay. All right. How can I prove that?
স্যার প্রতিটা ল্যাঙ্গুয়েজের জন্য ইউনিয়ন কনক্যাটার
Language
বের
no.
করার ট্রাই
We're
করি।
talking about finite automata.
ও ফাইনাল স্যার
How can I prove this? Tell me. See, let's assume my finite automata 1 is like this. Start, body 1, and start 1, body 1, and let's assume my finite automata is like start 2, body 2, and 2. Now F1, F2. What would be the case? We can do this thing. Start and end, we're going to merge this. So it become start 1, 2. We merge the start state and create a branch. Body 1 and 1 and body 2 and this is the union of finite automata. Now how about concatenate? Finite automata 1 concatenate finite automata. In this case, start 2 and end 1 would be merged. It will be like this. Start 1, body 1, then end 1 plus start 2, then body 2, then finally and 2. So this is the content. Okay. Finally, let's say F1 star. How can we represent F1 star? Very simple. Start 1, body 1, then and 1. Then what happened? Then what happened? We also make start 1 as a final state. Then we make a transition. Plus F1 star is also accepted. So it means finite automata is also closed under union, concat, and constant. QED proved. Now let's try to prove the main theorem. prove a main theorem. So how can I prove the main theorem? See, one part I have language, another part I have finite automata. If my language is empty, I have finite automata. This is the finite. Number two. If language is epsilon, we have finite automata, like this. Number three. If L1 has F1 and L2 has F2, then L1 union L2 has finite automata F1 L1 concatenated L2 has finite automata and L1 star or this star has. So we are done. The same way, reverse one we can also put. This to this to this. Okay, QE. Did you understand the proof? Did you understand the proof? No, sir? Right? Okay.
So তাহলে মানে প্রতিটা ল্যাঙ্গুয়েজের অ্যাসোসিয়েটেড একটা ইয়ে আছে
ফাইনাইট অটোমেটা আছে সেই কারণেই আর রিকার্সিভ যেটাও আমরা এটাকে দেখিয়েছি ইউজিং দিস লেমা সো দ্যাটস ইট ইজ
ওকে
ওকে let's continue the next topic. Let's continue the next topic. Which is called regex. So, regular language. Regular language. It has a acceptor which is called finite automata. And we know that it has a another thing called generator, which is nothing but regular grammar. Regular grammar of two types. One is called left linear grammar. Another one is called right linear. Okay, it has only the regular language has another thing which is called representative. Representative, and this representative is called regex. Did you get it? So there is special thing in regular language which is called representative, and it is called regex or regular expression. Did you understand? So what is the definition of regex? That is the question. Am I right? So let's take the definition. Number one, empty language regex is pi. A language which contains only epsilon its regex is epsilon. And number 3, alphabet A comma B has regex A comma B. Those are called singletons. And number 4, so এই তিনটা মিলে এক নাম্বার পয়েন্ট বলতে পারেন। আর নাম্বার 2 হচ্ছে if L1 and L2 if R1 and R2 are two regex, then R1 union R2, R1 concatenate R2, and R1 clan star are also regex. That means regex is closed under union, concatenate, and star. Should we stop here today? We should stop here today. Too much is for today. All right. If you have any question, you can ask me. খালি দিলেই তো হবে না, খাওয়াতে হবে। হ্যাঁ, বলেন। Are you sleeping, guys?
No, sir.
Oh, sir.
Why you people have lack of energy? How old are you, guys? How old are you, guys? Approximate. If you have any problem with telling the real age, tell me the approximate age. What is your approximate age? 19, 20? Am I right?
23,
No, sir.
24.
21, 22?
23.
Okay, not 23, not above 23.
24, sir.
The way you people are behaving, it seems you people are 65 years old. My dad, who is almost like 67, is still more energetic than you. And it is your first class. Am I right? Today, do you have any more classes?
স্যার এটা আমার লাস্ট ক্লাস।
Yes, sir.
last class.
Last class, sir.
So, how many classes do you have today?
স্যার আগে স্যার তিনটা করছে।
আগে একটা ছিল।
So, I'm taking almost consecutive 6-hour classes. Still, I'm not weak like you guys. All right, guys. এগুলো বলে আসলে লাভ নাই. Don't worry. I don't. Those are actually unnecessary. Let's take the attendance, the thing which you are waiting for. Then you can leave. Well, আপনাদের proposal. What is your proposal? To make quiz little bit harder and make the final very easy. Am I right?
Yes, sir.
Yes, sir.
Okay, sir.
জি স্যার।
Okay. It is your proposal. Let's stop. Let's discuss with
Sir.
other people.
Sir,
Yes.
sir, can you take two more and best two circles নিতে পারেন?
না, ওইসব কিছু হবে না। Nothing.
স্যার বেস্ট কুইজ নিলে ভালো হতো স্যার, যদি একটা কাইন্ডলি
Best
নিতেন।
Sorry.
Sir.
একটু ট্রাই করেন স্যার প্লিজ স্যার।
It is not possible. আর বেস্ট নিয়েও লাভ নেই, শেষে দেখা যাবে মার্কস পাওয়ার পর তো কার্ভিং এর ব্যাপার আছে, কিন্তু ওগুলা দিয়ে ঠিক হবে কি হবে না। ডোন্ট ওয়ারি, হ্যাঁ, ওয়ারি করার কিছু নেই, যেরকম আপনারা সেরকমই পাবেন।
স্যার ডেমো কুইজে তো স্যার কিছু বোনাস দেবেন, রাইট? আপনি কিন্তু স্যার বলছিলেন স্যার ডেমো কুইজে একটা বোনাস দেবেন।
মানে ইউ আর পারসুইং মি।
না স্যার, স্যার আপনি স্যার ওইদিন বললেন না যে ডেমো কুইজে সবাইকে একটা বোনাস মার্ক দিয়ে দেবো স্যার, এই জন্য বললাম আর কি।
ও আচ্ছা, ঠিক আছে, দেখা যাবে, দিব না।
থ্যাংক ইউ স্যার।
আমি তো বলছি কি বোনাস দেব, মানে আমার তো ব্যবহারই তো ভালোই। আমি বলছি যদি শেষে যদি 1 পয়েন্ট আটকায় যান, আমি একটা গ্রেড বাড়াই দেবো। বলছি মনে করেন 79-তে একটা গ্রেড আসে, আপনি 78 পাইলেন, সেটা আমি দিয়ে দেবো, সেটা বলেছি। কিন্তু আর তো কোনো বোনাসের বহুত সমস্যা। সেকশন 3-তে কি যে হচ্ছে, সেকশন 1 আপনার দাঁড়ান অ্যাটেন্ডেন্স দিন। হ্যাঁ, হ্যাভ এ গুড ডে। ঠিক আছে, বলেন। হ্যাঁ, কি হচ্ছে বললাম তো, বোনাস দেবো। মানে আপনি আমাকে খুব খারাপ মানুষ মনে করেন। I told you that if 1 marks, not 2 marks, I promise 1 marks, if you get stuck, that you get 78, but the uphold is 79, then I'm going to make you 79 and give you a grade because of attending the demo course. That is my bonus. I already told you. Right. All right,
জি
guys.
স্যার
So should we leave today?
ইয়েস স্যার আজকে আমি
স্যার একটা মেইল করেছিলাম কালকে আপনাকে, স্যার পেয়েছিলেন ওটা?
সব পেয়েছি, সেটা পরে। এখন আমি একটু ক্লান্ত, কাজটা
জি
দেখবো
স্যার, ঠিক আছে।
কালকে থেকে।
ঠিক
ওকে
আছে।
ওকে, টেক কেয়ার, বাই।
থ্যাংক ইউ স্যার।
আসসালামু আলাইকুম
ওয়ালাইকুম আসসালাম।
আচ্ছা।